In the first unit, the first topic we are going to discuss now, the elasticity of the material. Before entering into the elasticity, just we will discuss how many types of materials are in nature it is exist, how we can classify the material in nature. So there are two classification of the material. So we can ask one question. The materials are how it is classified means. So it is classified into two. The first one is that is amorphous material. We are going to look at what is amorphous material anyway. The first one is an amorphous. The next one is it is crystalline material. These are the two major kind of material exists in nature, or the existing material we can classify into these two category, the amorphous, the crystalline. There are several examples in day-to-day life. We are going to look at all the crystalline material, amorphous material. For example, one can say the gold, the wearing bangles or the gold bangles or gold chain, they are crystalline in nature. Suppose if you are using the rubber band or some other thing, they are amorphous material because they won't have the perfect structure. So now we are going to look at why we are calling some material are amorphous, some material are crystalline in nature. So that is the thing we are going to discuss in the next slide. The first kind of material is amorphous material. So what is amorphous material? Just we need to see an atomic level structure. Once if you want to classify the material, we want to know the atomic arrangement, then only we can say those materials are amorphous or crystalline material. First we can ask the question how the internal structure of the amorphous material is looking like that. Just see this diagram. If you see this internal structure, look at the atomic arrangement. The first atom is located here, the second atom is down, the third atom is slightly up, the fourth is slightly down, the fifth is even topmost, the sixth is slightly down. That means there is no ordered structure. The atoms are arranged in disordered manner or it is randomly arranged. There are bigger gaps, smaller gaps. So you see here, the gap is here is moderate gap. Here the gap is so small. Here the gap is bigger gap. So there is no orderly arranged structures. That's why we are calling this kind of material as amorphous material. Example, if you look at that glass, even window glass or any glass materials or atoms, if you are zoom that atoms, if you look at the atomic arrangement, it will be looking like that. So that is one of the best example for the amorphous material. There are several examples. Just you can look at the books to find it and then look at around you. Even you can call that some of the paint. I'm not calling the nano paint. The painting material. They are amorphous material. Even though it's a atomic looking like a outer thing is everything is looking neat paint. But if you look at the internal structure, it will be like a disordered manner. That's why we are calling that material is amorphous. You can take several examples. Now we can look at the next type of material. Second kind of material, that is the crystalline material. This is a crystalline material. So readily we can ask the first question, what is the crystalline atomic arrangement? For that I have given one diagram. Look at this diagram. If I see the first row, just I am giving that number, the first atom, second atom, the third, the fourth, the fifth. There are 6 atoms in the first row. It is orderly arranged. It is arranged in the straight line. Look at the second row. There are 7 atoms. Just if you are putting the number in the second row, it will come out to 7 atoms. It is slightly displaced from the first atom, but still it is aligned in the line, ordered manner. See here, it's arranged. Look at the third row. it's a 6 more atom. The first row as well as the third row, they are forming some symmetric kind of structure. Similarly, the second row, this is second row, the fourth row, they are equivalent to each other. They are forming some symmetric kind of structure. So they are orderly arranged. If you look at the internal structure, you can just draw either triangular lattice. This triangular structure, it will repeat. We are calling that as a lattice. Anyway, the lattice structure we are going to see in the fifth unit. Here we are seeing that this structure is repeating. So if you look at the top one also, it will repeat. See here, this is also repeating. So that's why we are calling this is a crystalline structure. It is orderly arranged atom. It will form a particular shape. So we are calling that shape is a crystal. Here 2D crystal, because I have shown here it's only using the two coordinate, because you can draw here x, here y axis. So any atom can be represented by two coordinate. That's why we are calling it's a 2D crystalline structure. Either you can form the triangular lattice, you can just arrange in the triangular lattice manner, or you can form the hexagonal lattice. See here, hexagonal lattice. This lattice in general 2D Bravis lattice. Anyway, that is the thing also we are going to discuss in the fifth unit. You can form like see here. So hexagon structure you can form, and then you can arrange it in the hexagonal structure manner. Just in the hexagonal lattice, you can fill up in uh, all the direction, like x direction, here two direction, in the y direction. Either hexagonal structure you can see the hexagon structure as a primitive lattice, or trigonal structure as a primitive lattice, but this structure it will repeat. The atoms also is so close, so dense, there is no gap, there is no defect. So we can call this is a perfect crystalline solid. So these are the two main solids that exist in nature. The first type already we have discussed, the amorphous solid. The next one is its gear, that is a crystalline solid. The elasticity, before entering into the elasticity, we categorize the material two types. That is, one is amorphous, the next one is the crystalline. Okay, this either the material is amorphous or crystalline, it doesn't matter. We can further classify the material into two types. The first one, that is the elastic materials. The next one, that is the plastic material. So what is the elastic material? What is the plastic material? That is the question we can ask now. So the first thing is we are going to discuss the elastic material. So the first material, the elastic material, we can ask how you can define the elastic material. Before defining, how you can check the elastic material, whether it is elastic or plastic, just you will give the force, or you will pull or push that material. Then only you can check the elasticity, whether it is touching, or it is bounce back its original shape, or it will retain its original shape, or it won't retain its original shape. So to check the elasticity, example rubber band, or you can take like some other rubber material or some other stuff. You can check the elasticity. So first thing is you got to define what is a elastic material. So the material body to return to its original shape and size when the deforming force are removed. So these type of materials are called elastic materials. So this property is elasticity. So this is a simple definition. A body retain to original shape size when the deforming force is removed. So we are giving external force, because of that it is going to some other shape, but once if you are removing that force, it will bounce back to its original shape. That's why we are calling those materials are elastic material. The property is elasticity. Look at this picture. It is taken from the source. Here, suppose if I'm just pushing this rubber band in this direction by giving some applied force FA. What it will do, internally there is a force it is forming due to the elasticity of the material. It is acting opposite to that applied force. That force is called the restoring force. That's why even after removing that force, it will bounce back to original position. The stretching it is explaining due to the applied force. The it's coming back to the original shape. It's because of the restoring force. Here look at the internal atomic structure. The bond is getting extended. See here, look at this bond length. So each and every atoms are just extending this bond length. So the interatomic forces are still there. We are not breaking, we are not giving the any force that to break this bond. That means the applied force is not exceeding the breaking uh, or it is not extending the internal force that exists in the bond formation. So that's why we are calling this material is elastic material. That means the applied force we are not giving beyond the material elasticity. So it will hold its elastic property. That means applied force is just it's a testing force to check the material elasticity. The restoring force, what it will do, it will retain its shape, original shape and size. That's why it is called restoring force. So this body is called the elastic body. This material is called a elastic material. Example for the elastic material is the quartz fiber. Look at this diagram. This is it's taken from the Wikipedia, Google. So it's a good example for the fiber. Look at that fiber. Here, the white portion, it is represented the white tube like structure. That is a quartz fiber. It is almost 99%. It's a elastic material. In nature, ideally, there is no elastic material. Just a man-made elastic material. It will attain 99% point or 99.2% or 9% that elastic property. No material having 100% elasticity. For studying purpose, we have for teaching purpose we are using the ideal elastic material, but in nature there is no perfect elastic material. The second example for the nearly perfect elastic material, that is the phosphorus boson, bronze. So the structure is looking like that. Even it's looking like the spring-like structure. So it will, even if you are pushing, if you are just compress this spring, it will retain its original shape. So this phosphorus bronze is best example for the elastic material. These are two. There are several examples. Why I am saying means these are the now it's available 99% elasticity. The unmanned material. The first one is the quartz fiber. The phosphorus bronze. They are having several applications. That's why I put this two example here. The kind of material we can ask, what is the plastic material? How you can define the plastic material? If you are giving the external force, how it will be looking like this? Whether it will retain its shape or it won't retain its shape. This is a question we can ask right now. So first we can give the definition. The material, it's going slow, so we can just discuss it. Once if it is completing, then we will define the definition. So the plastic material, what it will do, if you are giving the force, it won't retain its shape, original shape or size. Those material we can call it's a plastic material. Like example, which material we can say means like even if you have that water bottle, the plastic water bottle, just you can compress it. It won't retain its shape. If you want to like use and throw water bottle, it's a best example for the plastic material. There are several examples for the plastic material. Like if you are having your plastic teacup, we are using now exactly not plastic teacup. Even your chair, the plastic chair, now I am sitting in the on the plastic chair, just if you are breaking, it will break, it won't retain its shape. Then the dropping, like so you can put like the toys. There are several toys. The plastic toys are available for the children. They are plastic material. Look at this definition. The material body cannot return to its original shape and size when the deforming force are removed. So the external force is deforming force we are giving to deform the material. Once if it is removed, then the material, it won't retain its original shape after removing that force. So those material we can call it's a plastic material. This property of the material we are just telling it's a plasticity. Here I have taken that one example. One bullet is shooting on the plastic bottles. See, look at that. Actually, bullet is a huge force. It's an impulse force. But I should not put this example. I want to just show that bottle, the breaking bottle. See, look at the breaking bottle. It's breaking. After breaking, it is not retaining. It won't retain its original shape. So this kind of material we can call it a plastic materials. So any material, if the external forces, if we are removing, if it won't retain its shape, then we can call those material or plastic material.